Good morning, everyone. I wanted to walk through one of the homework problems to show you guys how to do a hypothesis test using my stat lab. So I think one problem that would be pretty easy to go through and that would help really illustrate what you need to do would be problem number 7. So this is number 7 from the module for my stat lab assignment. As you can see here, it says test the hypothesis using the classical approach and the p-value approach. So first we're going to go through the classical approach and then the p-value. So really quick, let us look at the two approaches in the little table that I include in the weekly announcement. It's on page 487 and 488 of the textbook. So for the classical approach, we're going to be calculating the test statistic and comparing it to the critical value. For the p-value approach, we're also going to be computing the test statistic, but we're going to be using that to find the area under the curve depending on which left-tailed, right-tailed, or two-tailed test, and then comparing that to alpha. So let's go back to the problem. So first we're going to look at the classical approach. So let's read the problem first. We have the null hypothesis is that the proportion is equal to 0.9. The alternative hypothesis, H1, is that the p-value is less than 0.9. Here we're given the number of observations, n, is equal to 150. The number of successes is 125, x equal to 125, and alpha, or level of significance, is 0.05. So let's start by going straight to StatCrunch. So go to question help, down to StatCrunch. And we're going to make that a little smaller just so we can easily type stuff in. So first we're going to go to stat, proportion stats, because as we remembered from last week, we're doing the proportion, not the mean. So we go proportion stats, one sample, and with summary. In this case, we have the summary data. We have the number of successes, the number of observations. We do not have a data set. So just like we did last week with the confidence interval, here we're looking at the hypothesis. The number of successes is x, 125. The number of observations is n, 150. So the hypothesis test is automatically checked. Last week we had to switch it to confidence interval, but here we're doing the hypothesis test. The given value from the problem is 0.9. And the alternative hypothesis, you see here they have h sub a instead of h sub 1. You'll see that occasionally. H sub 1 is still the more traditional, or what you'll see more often, but in this case it's still you can tell it's your alternative hypothesis, and it's less than. So you just have to make sure you select the right comparison. It's either does not equal, less than, or greater than. The problem here was less than 0.9. Once you've done that, you're going to click compute. This will give you a lot of statistics. So as I said in my announcement, I do recommend that you go through and calculate these manually once just to kind of understand. However, there's a lot of room for error or mistakes, and you can't do it in StatCrunch. That's why I'm showing you how to do it in StatCrunch. So here you can see our z-stat, or the test statistic, is negative 2.72165, yada, yada, yada. So let's look back at our thing here. And what does it say? It says, first let's find our critical value. So we are doing a left-tailed test. Let's go back really quick just to talk about that. On the table, you'll see here, there's a two-tailed test, a left-tailed test, and a right-tailed test. Our problem was given as the alternative hypothesis with p less than p naught. In our case, p naught is equal to 0.9. So we know we have a left-tailed test. We've gotten our test statistic from StatCrunch. So the next step is to find our critical value. So here we have our left-tailed test. I just want to point something out. When you're doing a right-tailed test, you don't have to do the 1 minus whatever. You can still look up the value in the table, the standard normal distribution table, because these areas are symmetric. So if you find this value, you can always use it without just taking the positive instead of the negative for the right-tailed test. If that's confusing, please let me know. So let's go back. We are doing a left-tailed test. So we know that our alpha is 0.05. We can do this a couple of ways. The first way would be to do what I call the reverse lookup. I did outline this in one of my announcements either last week or the week prior, how to do the reverse lookup. So what you would do is you would go in here and you would find the closest value to 0.05. 0.05 was our given alpha from the problem. So let's see, 0.05. I see, let me see, 0.05. So as you can see here, we have 0.0505 and 0.0495. Those are equidistant from 0.05, so we would take the average of the two. This is the exact example that I had in the announcement from a previous module to show you how to do it. So what we would do is we have negative 1.6. We know that's the beginning, and these two fall right in between 0.04 and 0.05. So then we know that our critical value is negative 1.645. Okay, so let's go back to our little table here. For the left tail test, if Z naught, our test statistic, is less than negative Z alpha, our critical value, then we would reject the null hypothesis. So in this case, Z naught is equal to negative 2.7216. Our Z alpha is equal to negative 1.645. So we have Z naught is equal to this number, which is less than negative 1.645, which is our Z alpha. Therefore, we reject the null hypothesis. And in that case, we would say there's sufficient evidence to support the alternative. Okay, so let's go plug that into our problem and make sure, reject the null hypothesis. Let's check that. Excellent. Next, we're going to perform the test using the p-value approach. It's going to look very similar. We're going to go back to StatCrunch. I'm just going to walk through it again. Even though we had the p-value in our results before, I want to walk through it again just to make sure it's really clear. So you go to Stat, Proportion Stats, One Sample with Summary. Again, you could have gotten these results from our previous run of doing this, but I just wanted to go through it again. X, the number of successes is 125, as you can see right here. The number of observations is 150 from right here. Again, we have 0.9 and less than 0.9. Click Compute. Again, see, we had our test statistic that we got and our p-value. So in this case, our p-value equals 0.0032. Let's go to our table, and it tells you if your p-value is less than alpha, reject the null hypothesis. Remember that our alpha was equal to 0.05. Therefore, our p-value, which is 0.0032, is definitely less than alpha. But first, let's actually plug this around to 4 decimal places. 32 to check our answer. Fantastic. So our p-value is less than alpha, therefore we reject the null hypothesis, which is the same outcome we would the outcome we would expect, since in part A we already reject the null hypothesis. Good job. So as you see, you get the same results from either approach. If the homework problem doesn't tell you which approach to use, just use what is easiest for you or what makes the most sense. But that's how you would do a hypothesis test for the population proportion in StatCrunch. If you have any questions, please let me know about any of the terminology I used, about the process, or about the concepts of what any of this means. So good luck as you guys work on Module 4, and let me know if you need any help.